Welcome back everyone to McCall Science Enrichment, and today's experiment is titled Spinning Eggs, and here are the materials that you'll need to perform this experiment. For this experiment, you'll need at least 2 raw eggs. You can use any eggs you wish. These are chicken eggs. They are large eggs. They are not organic. It doesn't matter if they're organic or not. And you'll need at least 2 of these eggs to perform this experiment today. You will need 1 permanent marker. I know I'm going with boring black, but it's good contrast and I like this marker, so this is the marker that I'm going to use. You will also need a small pot that can be heated on the stove. This is my smallest pot available. You'll need a lid to that pot, and you'll need enough water to fill that pot probably about 2/3 of the way. You'll also need a stovetop to be able to heat the water. And those are the materials for today's experiment. And now here are the procedures. Here we go. The first step for today's experiment is to place at least 1 of your raw eggs in the water in that small pot. Now I might need to add a bit more water here because I want that water to pretty much just cover this egg. Now, because I'm rather rough with eggs, I tend to boil them and my eggs usually crack. I want at least 1 boiled egg that doesn't have a crack. So to make sure that I have a good one to choose from, I'm going to do 3. Now what I'm going to do is I'm going to add a little bit more water to this pot. I'm going to place the pot on my stovetop on high, and when it comes to a boil, that's the spot you'll see me next, and we'll go from there. Hang on. Alrighty, once your egg water has reached a full rolling boil, we can turn the heat off, take our lid, place that lid directly on the pot to seal it, remove that pot from the stovetop burner to a safe place in the kitchen counter, and now we're going to let this sealed pot sit in that hot water for 10 minutes. We'll see you in 10 minutes. Alrighty, it's been 10 minutes. I've let my pot sit here on the counter for 10 minutes. I'm going to bring it over here to my sink. And you're going to notice when I take this lid off, there's going to be all kinds of steam coming up because water absorbs energy and gives off energy very, very slowly. So this water is still really hot. Here we go. There we go. Now, I don't need all this warm water anymore because these eggs are already cooked solid inside. So what I'm going to do now is I'm going to cool them down. So this is cold water now. I'm just going to let this cold water run for a little bit. The eggs will probably still float in this cold water. And I just want to begin cooling down the interiors of these eggs. I don't want to handle them when they're too hot. I want them to be room temperature when we do our experiment. Now, I'm going to let this water run for a bit, and then I'm going to let the eggs sit in this cold water for about an hour. It could take a little bit less, but just to make sure, I'm going to leave them for an hour, and then we'll do our experiment in 1 hour's time. See you then. Okay, everybody, the boiling process for our 3 hard-boiled eggs is complete. They have cooled in that cool water. I've dried them off, and they're all set to go. I am only going to use 1 of these hard-boiled eggs, but they came out nice. They have very few cracks on them, and they should be all ready to go. Now, I'm going to address now this single egg, which is still raw. This still has that raw white and yolk inside, and I tend to be kind of rough with eggs, so if I break this, I'm going to make a massive mess, and it's going to be very difficult to clean up, and it could start to smell. So I want to make sure that I have marked this egg so I know that this is the raw one, and it's not one of our safe hard-boiled eggs here. If I break this, this has consequences, and that would be bad. So I'm going to take now my little permanent marker here, and I want to put a large enough little black dot, a permanent dot on this egg so I know that it is the raw egg. And you'll notice if I roll this egg over, I've already got that mark right there. This should be enough, even for me, to know that this is the raw egg. So I'm going to work with the raw egg now. I'm going to take my little hard-boiled eggs here and just put them to the side. I can put my marker to the side. And you'll notice that the title of today's experiment is Spinning Eggs. But if I go to spin this egg on this cloth, there's too much friction. So I need something that has as little friction as possible. And my solution right now is a flat sort of like a luncheon plate here. This is fairly hard, but it's very, very smooth, and I should be able now to very casually spin that egg, and it's wonderful. Now, you'll notice the instructions are going to be the same for every egg that we spin today, whether it's raw or hard boiled. If I go to spin this with one hand, I'm going to spin it, and as fast as it's spinning, I'm simply going to put my fingers on it and touch it, and then let go. So it's spin, touch, and let go. And let's see what this egg does. This is the raw egg. So let's see what this raw egg does. Ready? I'll try not to break the egg in the process. Let's spin, touch, and let go. One more time. Let's spin, touch, and let go. That's the raw egg. Good. Okay, let's put that raw egg to the side. I'll try not to break that. And let me take any of my hard-boiled eggs. This is a nice one. I like that one. Okay, this has no black mark on it. This is a hard-boiled egg. Same process. Spin, touch briefly, and let go. Here we go. Spin, touch, and let go. Let's do a little less fast. Spin, touch, and let go. I'm going to do that one more time. Spin, touch, and let go. All right. That is everything. Now, what was the science behind what we just saw? So what is the science between these two very different spinning eggs? Now, in that last scene, when I used that purple plate, I wasn't really satisfied with the results that I saw. So what I've done since then is I've changed that purple plate for this little mini, it's sort of like a frying pan that I've got. It's brand new. And one thing I noticed with the purple plate was, for as pretty as it was, the surface of the purple plate was a little uneven. It was kind of wobbly, and when I put the egg down, the egg was sort of wandering all over the plate. Now I've put this raw egg down in the middle of this frying pan, and for the most part, when I let go, that's a bad illustration, but it's much more level. It's much more flat. And I should have looked for that in the last scene, but I didn't. So I think I'm going to have the answers for you for these spinning eggs. So here's the thing. Our instructions for both eggs was to spin it, to touch it, and to let go. And there are some differences between these eggs. I just need to make that a little bit more clear. So watch. We have our black dot here. This is definitely our raw egg. And here's what the raw egg is doing. I can spin it, I can touch it, and it still moves after my fingers leave it. Let's do that one more time. I can spin it, bad spin, Mr. P. Spin it, touch it, and even after I let go, it continues to spin. Now, that is different from this egg. This egg has no black dot on it, so this is a hard-boiled egg. Watch what happens here. See if I can make this clear. If I spin it, well, first of all, look at how it's spinning. These two eggs spin very differently. I can spin this raw egg, and it's not spinning as fast. I can put the same force as I spin it into the hard-boiled egg, and look how much it's spinning. There is a difference right there. Now, let's do the procedure here. Let's spin it, touch it, and let go. Spin it, touch it, and let go. Spin it, touch it, and let go. With the hard-boiled egg, when I touch it, it might wobble a little bit, but it's not spinning still. When I let go of the raw egg, I touch the raw egg and I let go, it continues to spin. Touch. Even after I let go, it still spins. The boiled egg's not doing that. Watch. Spin. Touch. No. These two eggs are behaving very differently. And why? The reason why they're behaving differently is this little word in science, it's very, very important, called inertia. Inertia. I know it doesn't look like you say inertia, but that's how you say that word. Inertia. And what's the difference between these two eggs? Well, this egg, this boiled egg, is solid on the inside. All that egg yolk and egg white is now a solid, and that solid is actually stuck to the shell. You can probably remove the shell when you go to eat this egg, but right now it's essentially stuck. There is no liquid inside this egg, it's all a solid. So when I spin it and touch it and let go, That inside is attached to the shell, and when I touch it, I'm touching everything. I'm stopping not only the shell of the egg, but the inside. So when I take all that spin away, it stops. The raw egg is not behaving that way. If I spin the raw egg with enough force and touch it, it continues to spin. Why? Because the inside of this egg is a liquid. It's a semi-solid, but it's mostly liquid. If you spill this egg, you're going to say, oh, that's a liquid. The white and the yolk are liquid, and they're not attached to the shell. If I shatter this egg right now, which I don't want to do, I'm going to end up with a shell and a whole bunch of stuff that's moving away from the shell. The content of this egg is not attached to the shell. So when I spin it and stop, oh, that's a bad illustration. When I spin it and stop it, I'm stopping the shell, but the inside of this egg continues to spin. Not so with this one. When I stop it, everything stops because everything inside is a solid. Everything inside of this egg is a liquid. If I spin it and stop it, I'm stopping the shell, but the inside continues to spin. And that's what's called inertia. Now in science, inertia says that an object at rest tends to remain at rest. And we can test that right now. Now, eggs are a bit wobbly. If I stop that egg and put it down, it stays. An object at rest remains at rest unless an outside force, which is my finger here, moves it. Now, once I take that outside force away, it goes to rest again. An object at rest remains at rest unless an outside force moves it. So, this egg, once it spins, wants to keep spinning. And if it wasn't for friction of the contact with this frying pan, it would continue to spin. So, inertia keeps this egg spinning after I touch it. Inertia stops this egg after I touch it. And the weird thing about this experiment is, for as simple as it is, this concept touches on Earth and space science. Because, as you know, our Earth is a sphere. Or is it? Okay? Our Earth is not a perfectly round planet. Our Earth tends to bulge left and right. Our Earth is a little flatter top to bottom, just like this egg. Our Earth is not necessarily shaped like this. Our Earth is shaped more like this. Now, it may not be as dramatic as this shape that you see, but if this was the North Pole and this was the South Pole of our Earth tends to bulge here, and it tends to bulge here as it's spinning. Now, why? Why is it that shape? Because the Earth is 2/3 at least water on the surface. Water is very, very, very heavy. And as the Earth is spinning, that water tends to collect here and here. And it's also true that as our Earth spins over time, it wobbles. This point here at the North Pole tends to wobble over time, just like this egg. So, does our Earth have inertia? Absolutely. It's hardly ever going to be the case that our Earth simply stops moving like this. No, it's going to be much, much more like this egg. Remember, there's also molten liquid metal on the inside of the Earth. At the core, there's molten nickel and there's molten iron. And the Earth is much more like this raw egg than the Earth is like this hard-boiled egg, okay? The inside of the Earth is somewhat liquid, and it does tend to wobble just like this raw egg. There are many, many questions I'm sure you have about this experiment, but I do hope you get a chance to try this at home. Be careful of raw eggs. They can get out of control very, very quickly. If you hard boil an egg, I hope that you enjoy a hearty dining. I'm going to make some egg salad with this particular one. But listen, I'll take your questions right now in class. If you have questions that you want to email me, that's great. Have fun, everybody, and kumbaya, and I hope that you have fun next time on McCall Science Enrichment. We'll see you soon. Bye-bye.